Now I am planning to measure the SWR of my CP22E VHF antenna. But I will be testing both VHF and UHF ranges, as I have been able to use this CP22E antenna for both VHF and UHF ranges. That is because UHF amateur radio band is the third harmonic, an odd harmonic of VHF amateur radio band. I have been able to work satellites, both VU satellites with uplink or we transmit on VHF and receive from satellite on UHF, that is VU, as well as with satellites having uplink, that is we transmit on UHF and receive from satellite on VHF, that is UV satellites. So I would like to test this VHF antenna for both performance on VHF and UHF. I am using this jumper cable. This is SMA male to SMA male jumper cable along with an SMA female to SMA female connector. All these came along with the NanoVNA. This is an additional connector which I purchased, SMA male to SO239, for connecting the PL259 on the antenna cable. First I am setting the frequency range. Stimulus. Start will be set at 140 megahertz. Stop will be set at 440 megahertz. So we can see that the range has come here, 140 and 440. Next I am going to connect this SMA open connector. SMA open connector for calibration has been connected. Now I'll use calibrate open. Before that I have to reset the calibration. Calibrate open. So the open calibration is done. The SMA short has been connected. Now I'll press short. So that has also been calibrated. Tick mark has appeared. SMA load has been connected. It has a silvery color. Now the load has also been calibrated. Now I am going to save it to SD card. I will save it in channel 2. So 2 calibration has been saved. Now this SWR chart shows that there is a minimum at 146 megahertz, that is 1.216. Then there is a dip at 179 megahertz with SWR 1.323. Then there is another dip at 251 megahertz with SWR of 2. I can see a more prominent dip at 440 megahertz, the upper limit which I had set. There the SWR is 1.8. So a dip is there at around 440 megahertz. That could be the reason why I have been able to use this for satellite communications. There may be some imperfections in my method of SWR measurement, which I'll have to perfect later on by multiple efforts. Now I am trying to check a different range. With the start maybe 135 megahertz and stop at 150 megahertz. See what happened? There is a dip here. This gives a more accurate measurement of SWR 1.095, that is less than 1.1 at 144.9 megahertz, because I have set the limit lesser. I am changing. This is a different range. So the SWR is 1.825 at 440.850 megahertz.